Whoever invented fiber optics was a genius. It changed an era. It allows you to receive information from anywhere in the world. Now let me take 3 minutes of your time. I'll show you how fiber optics work. Before we do that, let's review some basics. The speed of light in a vacuum is about 300,000 kilometers per second. When it passes through other media such as air, water, or glass, the speed changes. If you take the speed of light in a vacuum, with the velocity in the medium, you get the refractive index. Next we go through a little experiment to learn more about the changes that occur when light passes through to materials with different refractive indices. When we turn on the laser pointer underwater, the beam is slightly deflected as it travels from water to air. This phenomenon is called refraction. If the beam angle is adjusted, when bringing it to a critical angle, it won't refract through the water into the air. It's completely reflected back underwater. The phenomenon is called total internal reflection. In a nutshell, is that when light travels from a medium with a higher refractive index to a medium with a lower refractive index, the interface between the two materials becomes like a mirror, reflecting light back into the original material. This is the basic principle of optical fiber. Next, let's take a closer look at how optical fibers work. Optical fibers are made up of 3 main parts: the core, the cladding, and the sheath. The core is a transparent filament made of glass or plastic. And the cladding is also made of glass or plastic, but it has the same refractive index as the core. The protective sleeve is made of materials like aramid fiber or steel, protecting the core from physical and environmental damage. When the beam enters the core, it is reflected every time it reaches the edge of the cladding, and then transmitted along the fiber optic cable over long distances. Fiber optic cables are divided into 2 types: single-mode fiber and multi-mode fiber. They are different except for the core size. They also differ in terms of optical signal transmission. The core of a single-mode fiber is usually only 9 microns. This minimizes signal loss as light travels in a straight path, ideal for long-distance propagation. Multi-mode fiber has a core diameter of about 50 to 60 microns. This large core makes it possible to transmit multiple optical signals at the same time, although this has a higher data rate. But the signal is degraded over long distances, so multi-mode fiber is better suited for short-distance applications. Now, let's look at how optical fibers transmit information such as telephone or internet signals. We all know that any information can be made up of zeros and ones. Suppose you send a greeting message to a foreigner on the other side of the world. The word hello would be converted into binary code, sequence of OEs and 1Es. After the conversion, your phone will be in the form of electromagnetic waves, changing the combination of amplitude, frequency, and phase of the wave. Pass this binary code of 0 second and 1 second to the signal tower. The signal tower then uses light pulses to carry the information into the fiber optic cable, through the forest, climbing over the hills, after entering a complex network of cables such as under the sea, passing to a cell tower near the foreigner, and then send it to his cell phone in the form of an electromagnetic wave. This process not only transmits information but also puts images or video and other data into binary optical signals for transmission. The advent of fiber optic cables revolutionized the way we communicate. It's made it much faster and easier to communicate with our friends in foreign countries.